1, 2, 3. Okay, let's remove this. Feedback some message. No, this one. So, continued work on the performance test bed. Here. Where we basically will print the time before a function gets called, and then after the time how long it took, and then again for the second time, which will be the update camera function, which is currently the C++ function. So I'll probably we'll just leave that. We'll now check how it compares. Well, with the blueprint function. Previous stream it had a comma in there, which was now fixed to print the time. Because to get the accurate time you get the seconds and the partial seconds, and when comparing them later we were here because we were getting negative partial seconds when we compared them, because added the seconds and the partial seconds together here, because before we didn't. And then, is that now correct? Probably. We're adding the partial seconds together, get the float out of it, and then deduct seconds from it, the TB seconds, which is not the seconds anymore, which is basically just the TB time. That's wrong, confusing, just because it's not seconds, because it's why it is seconds, it's with the floating point, so we can just leave it at that probably. Let's see what it does. When we do this performance test bed, we call that in our event graph, where we had or have the update camera function, which was in blueprint at first. Now this is custom event, we still need to change that. Performance test bed. So we call performance test bed, which calls both of these functions. First the blueprint function, then the update camera function, and we'll see the time difference, and it loops through them 1,000 times here. We can give the time delta, which we get from the tick, that's the delta seconds, how much time has passed since the last tick is called. This could be different than the frame time, because the tick can run on a specified amount of time, so it could run every 0.5 seconds, 1 second, 3 seconds, or whatever. This is just a setup of Unreal Engine. So you don't have to call tick every single frame. If you set it to 0, event tick, the tick time, then it will call it every single frame, which at the moment it does actually. So this is just the time passed since the last frame. This is just used in the update camera function, which is basically this as blueprint, where it does some interpolations of the values of the rotation of the main camera here, and sets basically its relative rotation, which is basically here set up under the camera boom. I'm using 3 camera booms because one camera boom just gives you like one spring arm, and to make it more interesting, there's more string arms that are children of it with different basically values of the lag speed of that camera. Well, this one has this one, that's the same as that. Yeah, those are 2 short ones. And so it actually get a nicer kind of camera than using just a single camera boom. Which on this camera boom it sets also certain values, which you can see. Camera in here. The camera boom, it sets its the socket offset of the camera boom, like the XYZ offset of it. And what else does it say on it? Here, the length of the camera, it basically interprets it to the current camera length and sets it to this like default camera length far, or the cam arm length, which is set somewhere else. Well, here, actually, cam arm length, that's the target arm length. Cam arm length. Target arm length is correct. Yeah, the cam arm length gets set somewhere else. Cam arm length. Where do I set this? Searching here in the wrong window. Here. Get set here. So it sets it basically here on the delta. If you press a button on the gamepad or keyboard to the default values for far and near, that's when you basically aim with the controller or the keyboard. Here, that's normal, and now we aim, zoom in, that's that part. And so we have this function, and we created it in C++ as well after, just to make it faster, because it's a function that has some calculations in it, gets called every frame. I just thought, why not, let's make that one of the first functions from the player character to turn into a C++ function. And here it is. Maybe we can enlarge in this. And as you can see, it does the crouch offset and the right shoulder, which it's basically here, crouch offset, and then, well, the relative rotation, which is set here. So it's basically just written out the whole thing in code rather than the blueprint, because blueprints are known to be slower than C++, because C++ is native and blueprints are interpreted. So basically we have that, and where's the more updates. To get back to the event graph to see where the tick is. So here, just basically calling first. I was calling this, so I made a C++ function called this, and then basically compare them in here to see, like now, if I would call them 1,000 times, because it gets that from the iterations parameter here, 1,000. So it loops through with a for loop and calls first the function for the blueprint function and calls that 1,000 times, prints how long that took, and then prints out the time before calling the C++ function, which is here. And this one it also calls 1,000 times, and then it calls how long that took. And so we're gonna see that on screen and in the output log. So we can just run it. At the moment the frame rate is slower because we're calling that blueprint function 1,000 times and the C++ function 1,000 times. And you can see the values there on the left. But yeah, keep going, continuing to go. Now that it is a bit touchy. So we get that in the output log. We'll look for that, and we'll see here time before, time after. And that's one cycle. It's not clear yet which time before. So the time after delta time. So here that's the blueprint one, and that's the C++ one. Don't know. So in the previous stream, it was streamed how it got to there, although now the values seem kind of there. Let's just make this a bit more clear. Towards the back. And make it time before first. First comparison. First calls time after first calls. First calls time before second calls. And time after second calls. It will be less confusing. I forgot to say, yeah, those are that's the print time, which saves it to the TB seconds and prints it out, and then after the saved value gets added, subtracted from the current time to see how much it was delta time. So and then now I should see it better. Blue and bright. So that's maybe enough. Okay. Go back to the output log and go to the bottom. So here, time after first call is, what is 1,000 calls? 0.07. Time after second calls is 0.09. The delta time. That's actually strange. should be less, because it was always less. This seems more accurate, but the Y is here. And the other thing is this function, it actually does more now. It does the shoulder collision update as well. So to compare that, we would have to move the shoulder update also in there. Shoulder up, or update shoulder. Update shoulder, what is it called? It'll be here. Shoulder collision update PP, that's the one. And we don't want to do this anymore, because we'll call it from here. In the C++ function, it calls it right at the beginning, so maybe we'll change that around. It doesn't make a difference though for the time, or it shouldn't. So this is actually what's gonna get called in both here and as well as in here in this update camera function. So it's correct now. Get some values. Okay, look at those values. So the last one was here. So it was 0.14 in blueprints, and in C++ 0.0698. So more than 2 times faster in C++. That's now more accurate. Yeah, it's everywhere on each call. It is higher in C++. Well, the numbers took longer in Blueprint than in C++. To make it more obvious, let's use 1,000 or 50,000. That was around a good value from yesterday. Around 50,000. So the performance test is here. No. Wait. I do it 50,000 times. 50,000 times. Here. Okay. Yesterday we figured out a lot of this time is actually the for loop itself. So when you expand that, it's quite a bit of it's assigning values, and it's doing a sequence and then incrementing the local integer, which is assigned as the first index, which comes in as 0, and then it increments it to do the loop basically until it is smaller or equal to last index. So as soon as it becomes higher than that, the loop stops. So I was thinking this has a lot, loop might possibly could also do without the sequence somehow. Because when you do something over and over, like using for loops, they're quite expensive when they're done in C++, in blueprints. If you have iterating through for loops in like an enemy, and you have 50 enemies, and they all iterate through for an array of 100, or this can quickly multiply just in the usage of this for loop. Itself. So, because the thing is actually, if you see those times here, we got like 0698, 007. If you save this bunch here, we saved them. I'll look later to compare. That was the second one from yesterday. So if we could just do that and call this here for I should just call that times 50,000. So we loop it through it 50,000 times here, and end the loop here. Save that. And I want to take this into account here because it's used as well on the other. Didn't have it in there before. Now we do. So that's here. We're gonna compile that. Did we save it? Is it saved? Looks like it's saved. And we're gonna compile this from here. Live compile. And the live coding. So be compiled. So look at those values when they're added. So 069, 07. That's on blueprint round 4. That calls. So it's 2-3 times faster. Well, not always. Generally around 2 times faster. Here it's almost about 2.5 or so. It's compiled. There we go. How are we going? Here. Now, so this loop happens now in that function. I didn't want to double click it. So we can just skip that. We'll skip that for loop. Move that here as a normal flow. This is not going to be done anymore. And we just update it here. It does the for loop 50,000 times. Here we'll still leave it. Here it still does the camera update and for loop as blueprints 50,000 times. So we run that. get a few numbers. I get some numbers. Okay, we got some numbers. Let's copy those numbers. Let's compare them here. So from here it started the new version. Let's have a look. This will be 7. That increased quite a bit. Why did that increase so much on the blueprint side? On the blueprint side increased massively. But I didn't change the blueprint side. And it decreased on the C++ side by like a factor of 10, 100. I'm not sure. Because I don't trust these numbers fully. And this one, 003, that's 50,000 calls of that. That's 50,000 calls of that. It seems incredibly low. Those were the ones before. I mean, if we just take that number of the blueprints, for example, and see how many times it contains this number of the C++ divided by 0, that equals 5,011 times. So could have called the C++ version 5,011 times. It would be on the CPU the same amount as that. Although I'm not sure the interps, if the interps and all, whether they run on the CPU or on the GPU. It's possible that under the hood it might be done on the GPU, I'm not sure. Static context version force inline hint, because it forces it to be inline, and then I don't know, I might have compiler settings or something. I'm not sure about that, but anyway, those numbers seem extremely low for C++, extremely high for blueprints. I'll just double check this again. It's the update camera function. And oh, around here. We're adding the partial seconds to the seconds, storing it as seconds, printing it out as seconds, then calling our for loop 50,000 times, roll the collision update and update camera blueprint. And after I get the time again, add it together, gives us the seconds and the decimals after point whatsoever seconds, and subtract that, which is the time, the continued time from the ones we stored, so we get how long it took. So that seems okay. And we call it here. We print it out before the call. We print it out with the time passed after the calls, and do the same for the C++ version. Only here it's looping 50,000 times through. So what I think is maybe it optimizes it away. The compiler optimizes this away and doesn't actually loop through this 50,000 times. So under the hood something else may be happening. That's the only explanation. Or it's really much faster than C++ than blueprints. So we breakpoint that here and run it again.
I am a HAL 9000 computer.
II0 or step, right? Okay.
I am a HAL
Still
9000 computer.
yeah, same problem as yesterday. So can't debug it because it's been live compiled from the editor. So you have to compile it through here from the IDE and get them, so we're able to breakpoint it. Also may have then actually just call it once and the other one 50,000 times, so that's the more logical explanation why the number dropped so significantly. I mean, it's impossible. It's 500 times faster. I mean, possible it is, but I don't think it's going to be 500 times faster. So it's compiling when it's doing that. I'll just go check it again. Here, there's the levels. So theoretically it should step through it 50,000 times now, without there being a problem. So if you do that, breakpoint it and then get the time later, so the first one should be massively higher because we breakpoint it. It's also a thing to note. Let's just clear the output here. Maybe that one as well. Clear that one, clear that one. So we get a fresh output of numbers. We'll just start it quickly.
I am a HAL 9000 computer. I am a HAL 9000 computer. I am a HAL 9000 computer.
Actually, it does not go.
I am a HAL 9000 computer.
It does not iterate through 50,000 loops. I mean 50,000 times through this loop. It just keeps staying at 0. 0 minus 50,000 plus. Here maybe. Like 100 times. So because it might detect we're doing nonsense here, calling that 50,000 times, and just removes that in the compilation.
All systems are functional.
Which actually it shouldn't do. Think of it, you tell it to do that, you should be doing that, so. Come on. So slow loading this. So I was wrong in the last stream as well, because it just called it once and we compared it to the other one, but it was strange. If it was 510 times faster seemingly, that would have been just knows how long one time of that call goes. 510 times. 510 times faster, it's not possible. So we still don't know quite what's going on. Maybe that's just a wrong assumption that these for loops are so slow. Maybe they're not. Well, they add a bit, but we'll see if this now will go increment the the index here, and looks through all 100 or not. Set another breakpoint here, so it has two, like, here. We'll try that out.
I am a HAL 9000 computer.
So yes. 0. Where's the icon for continue? I don't know. I'll just use F5.
I am a HAL
Get
9000 computer.
where's the yeah, we're still on the same one.
I am a HAL 9000 computer.
Here we should be on 1. It means we've not gone there to there. We'll quickly test this. Just keep a static one. Static and x equals 0. X plus plus. X plus 0. setting it to x999.
All systems are functional.
Just check if that x is actually 99 before it sets it to 99,999. It should actually be 99 when it gets here. If it's not 99 and it's 0, it means it only executes the body of the loop once. So, just to see our theory, if that's the case, it optimizes out the for loop and just omits it. I'm thinking possibly the compiler does that, who knows. I mean, we'll just go that if we do this a lot, we'll just end up at those values and this might not even interrupt them. They might become values that are just fixed. Although we were able to step through, because it does hold us at least once, but then not for the other iterations of this loop. So let's see.
I am a HAL 9000 computer.
X is 1.
I am a HAL 9000 computer.
Just a 1. Y is 0.
I am a HAL 9000 computer.
This is 2, but I is still 0. It never gets here. Let's set a breakpoint here.
I am a HAL 9000. I am a HAL 9000 computer.
X here is 2. And well, we're still in the call before drawing, so essentially we might still be in this loop. Maybe all we need to do is to clear this like that to make it more obvious. And I0 looks through it, XX. Doesn't exist anymore. As long as I have a 0. Let's go there. Break point here.
All systems are functional.
Because it might be a scope sync or the debugger and the for loop. or something. This as well, just print it out on here. Find some printout thing we can copy. Where is this? Nowhere. Let's do it from scratch. Was it NS log? Or was it NS log? NS log. Project find. What's it called? NS log. No, we don't have it here. Why am I using this? Here, UE log. It's a UE log. One player character. Just test that, test compile. I'll add the UE log in the meantime. No, we want to breakpointers first. Come on, load. It's not loading this. Initialize the one, come on. Okay, test it out here.
I am a HAL 9000 computer. I am a HAL
Still zero.
9000. I am a HAL 9000 computer.
That's annoying. I must be doing some obvious stupid shit. So I can't just for loop int I plus plus. But you can't breakpoint the other iterations. I'm not sure. I'll just hit it here and call it nothing camera iteration. And this is D. This is I here. As a parameter. Multi-camera equals if it doesn't print that out, it's not iterating through all of those. I mean, if it only prints them out as 0, then it's not iterating through all of those. Compile.
All systems are functional.
So what were the numbers? Those from yesterday's blueprint only calls. Time after first calls, before second calls. Yeah, we got about, similarly 2 times faster. One here. And today's, well, that's with the loop being in the update function here. And here. Just for testing. Come on. Because that turned out to be like sometimes up to 500 times faster. Or here, that seems an absurdly high amount. I mean, low amount. because that's in there like a few thousand times. I don't know. Here it is, divided by that. Let's divide that. Now we go almost 6,000 times faster. It's for sure not possible. There we go. Now we're here. Okay, now we don't need a breakpoint, or maybe we do once put one here.
I am a HAL 9000 computer.
I didn't log it. Again.
I am a HAL 9000 computer.
What is that? Engine extras Visual Studio debugging. Server logged in. Never seen that before. Failed to load file. It is up the camera II00. Okay, next should be 1.
I am a HAL 9000 computer.
But it's not, it's still 0. Should be getting 100 of these messages going from 0 to 99. It's obviously not doing that. Well, no, we don't see it here on screen. Those are the ones here. In the log. What does the output give us? After second call, before second call, just as II0, but it doesn't iterate through it. Odd. So odd. What am I missing? Ask the Oracle. Where's the new window? Logging behaves a codeful path. Output logs routing and message patching. When a loop prints 100 identical rapid fire warnings, simply you might only see a single line. You know, to fix inject the looped index directly into the text font. So each line is unique. good. Let's be done. So it's not doing that. Pointer check. Maybe we do that what he suggested. Let's do another log here. Here's 10 no. Well, let's level 5. That should give us like 20 outputs or so. Great, let's see if this works via live coding. Let's breakpoint that. Oh, we'll breakpoint this one. Come on, set the breakpoint. Okay, no other breakpoints. Then it's compiled.
I am a HAL 9000 computer.
What did we get? -0.
I am a HAL 9000 computer.
Still 0. Output get some values and log messages. And then there's log. Unreal Engine log. Time here 1 second and 1 second. It's always just 0. That is weird. Well, Alright, each having so as a test it only analogs the 0. Oh, the IRR 0. Hiding in the middle of it. On the very first iteration. Oh god damn it. Yoy. No? Ah. Yeah. Yeah. Thank you, Google. Gemini. Fucking hell. How long did you spend on this? I'm a total idiot. God damn it. So, the reason for this return was... Oh, I think we were doing something else there. Before that, didn't you wanna... So, it was not the blueprint's fault. It was my own fault. Stupidity. Now we don't need that.
All systems are functional.
If we get values from 0 to 20. No. 0 to 100 in steps of 5. Then we're all good. gonna be all good. Come on. Load. I can't believe I missed the return. I really can't believe I missed this return. I'm getting Alzheimer's. Load. I could load this every time as a default, but the reason I'm not doing it is in case of map crashing, so I don't load the last map by default anymore, because if the map is kinda crashing, when you load it, you have to go into the delete some stuff or change some config files or do the project build for again sometimes, because if I just load into an empty level, it's for sure not gonna crash every time it starts up. So it's easier to figure out why it crashed when it starts up. So what we're doing is testing to see if we get this log out of the function. Come on. Because now we are weapon equipped and targeting. That's the whole reason we have this. Although I'm not, there might be a mistake here. Possibly. If the weapon is not equipped, if it's equipped, then no, the sprint, it'll do that, essentially. Yeah. You should just equip the weapon and then not sprint to get the right, correct values. If this was the case, why didn't it right? So okay, I have enough values. Where are values? Here on the bottom. Yeah, we are now getting the whole loop. So we can make this 50,000 again. We don't need this anymore. We'll leave it in there just in case. So we do 50,000. And then I should be able to live compile that. Clear log. Open R. Assets, current, last, recent assets. This one takes a long time to load. It's loaded. Okay, performance test 50,000. Go through that 50,000 times. Then, when it's finished, call the C++ function which loops 50,000 times. And then check out what's the difference. We could just also save the first set of values and then second set of values, and then compare which one was higher, lower, and what percentage it was. Let's get some values. now it's significantly slower frame rate. It definitely calls both 50,000 times each. Oh, pick this up, I need some values. Now at this frame rate I can't even pick up a weapon. Okay, get some values. I use these values from the end. Let's get them here, they're easier to get here. Not here, here. So last few values. Time after second calls. Time after first calls. 80300. It's not what I expected to see, to be honest. I mean, that still means it's about 500 times faster. Maybe even more here and here. That's not possible. We don't have a return in there. We are calling it 50,000 times. So, but let's remove that, just call it once. So it has this little nonsense. So that's that. We'll move this back where it was. Come on. Ah, the whole thing. Like that. And here, we'll just call it once as well. So we'll skip the loop. Now, put this up to the other one. So this bit we're gonna skip. That bit we're gonna skip. So it calls it now once. And this once. But this time might be too small. So there might be nope. So output, go to the bottom. Where are we? Time before second call. Delta times 0024. After first call. Before first call, second call. Where's the other one there? 002 and 00204 002115. This actually means the blueprint calls are faster than the C++ calls. This is correct now. Before a second call. Now we still have these log messages in there. And these log messages take time as well. Maybe I still log it. No, we don't. It's still running the old code. So compile as how they did that. Or I was checking the wrong place for the numbers. This is the bottom of the file. clear that. So, fresh new data. Close that. And we go clear that too. Fresh new data. See what's happening. Picking up, going around. That's enough. Output log. Time after, so we're only interested in those deltas. 0, 0, 0, 0, 2, 0, 0, 0, 1, 4. 0, 1, 3, 8, 0, 2, 5, 2, so over 2 times faster. Yeah, that's the thing that still makes sense. Let's do that anyways. With the loop. But we'll also do it for the C++ function here. Completed, we remove that. Because we have a loop found, maybe here too. So it was around 2 times, and it's run on as just one function. Does that make a difference calling a blueprint function or calling a C++ function 50,000 times? We will see here if it does or not. When the frame rate is low, that's expected. We're calling each 50,000 times. Okay, probably have enough numbers now to have a look at. Go to the bottom of this. Okay, first number 03575 3577 359707 359723 350777. Yeah, it's about the same. I'm still confused as to why. We make it 4. What did the Oracle say? Collapse counter. Like we did that. And so we mentioned check. but if you use the load messages, they will take times as well on the 50,000. wanna open the map. Open the map. Run it. Alright, so load is another map. But it's testing. Why do you need to build navigation? What is it? Pawn. Okay, this is now very, very slow. Because we used all these log messages. Guaranteed it's the log messages. I can't even get to the weapon. Let's exit that. And we check the values in here at the bottom. Here's one. Okay, it does actually now print all of these 50,000. Okay, that means it does iterate through all of it. How long would that have taken? What's the second time? 3.62 seconds. And that's 50,000 times. Where's that? And can't even get one. 50,000. 32. 110. 5. Jump still forward. Just curious. Come on. Get me in between. Second calls. That's easier. There's always a two. And after. Not getting it. Still call the following or not? Not sure. Maybe I need to delete this. Break for sure. Break that off. Save. Not some remnants of the ashes. I need this monk. on, rest. Now we want stop log. Okay. The unprompted after second cast 3.4. Get out of this completely again. Let me just pick it again. Yeah. Let me remove that. This. That. Saved. Build. Go for the move.
All systems are functional.
Yes. too. Takes just as long to load. Oh, it's because it's level sequence of stuff in there. Or maybe some. How long does that one take to load? Where is it? There's map, 3D modeling map. Yeah, that one's much faster to load. Or maybe because it's already loaded one. I don't know. So from here. Get some values here. Okay. 3D modeling map, so this might be the fastest one to load. Go check the numbers. No, where is it here? Go to the bottom. And then the numbers. Here. Okay. That seems more realistic. Could also be that there's much less stuff in the map, and if you loop in, so it seems much more realistic and consistent, more or less. Let's take this. One, two, three, four, 6 digits. 1, 2, 3, 4, 5 digits. I just used that one. 0 point. Here. Where is the calculator there? Divide by. Where is it here? That's the first, that's the second. Equals 377. Let's put this maybe in there. Recent assets. Right there. Go. Seconds. Print past. Maybe save the seconds as the first. And then get the value. And have to have a different event function. is it? Although, if I do that, plug it in there, compare first before, maybe it alters and does this whole calculation again. I'm not sure. Whether it calculates that again. Well, if we do it after that, we'll see if that's what it does. Just do it after the print and see if the print is different from what it says here. Equal, say equal 1. Do that. If this equals 1, we'll save it as the first result. If not, it'll be the second result. Look at that as well from here. And then we'll breakpoint that. This one and this one will breakpoint. And then this will be the second. Ayoy. Just go there. Which result? This is 2. This will be 1. That was which result? There. Save, compile. Okay, going through here. What does it print out? Nothing. Here. 721949. 722127. Ah. Is that really the last one? Yeah, 721949. 721949. But this is 722127. Well, it's 50,000. See what it does on the second one. Okay. What did he give me? He gave me 214195. 214463. Because that execution also takes some time. So move that up. Move that over here. So like that. We'll get that over here. mistake. Don't do anything here. So I need to do this string. The second result. That comes in now. Again, this will be, you would have to change that to go in there. This goes in there and that goes in there. So the values will be the same. Basically, just that will be added to the time it takes. So it's not going to be accurate. Second, yeah, you need to duplicate it, there's no other way. I'll duplicate it. So I'll duplicate this. And I made a mess. Why did I make a mess? This goes up here. This goes up there. That goes up here, so now it's duplicated. And then we don't need that anymore. We don't need the second parameter anymore. Same here, remove the second parameter. Print time past second. And this one will go first. So we're not using a second value anymore. And just the first one. And delta time over that. Because otherwise it might call this again if you plug it into there. So cache this here. Delta's time. Print past second. Second. It's dark on the keyboard. Can't see the numbers. Second, that's first. Correct. be the same. That's the first result. Delta time, first result. First result. Delta time, second result. And here we're just using the second one, get rid of that. The first one's go. Second one, so where does that go? Guess it from where? First result. 2 seconds. Some mistakes. Why is that? That's not the delta time. That is the delta time. This was that, which would be inaccurate. No. I made a mess. So that one, first time, isn't it? Just saw the TB seconds. Minus TB seconds. Delta time first result. No, what did you want to print it? Delta time first result. Yeah, that would be the TB seconds, which goes in here. Okay. TB seconds goes in there. And then like this. So we got the first result, second result. And after we can compare it, print another string. Difference or difference factor. Difference factor. It's not a key. Goes there. And difference factor. Which will be the first result divided by the second result. Is that correct? First time to the second time. And that will be the factor by which it's different. Let's see if that's true. Something else. What's going on? parameter anymore. I can remove that parameter now. Just put it in here. Time passed after second calls. Same with that. Not need that parameter anymore. And just call it in here because we have to do it often. Time after first calls. Just remove that breakpoint. So we need to refresh all nodes. Didn't work. Refresh that. Refresh that. This needs to be call second. Print out the second with the result. Print by second and result. Let's get our numbers. Okay, that's some numbers. Where are the numbers? Go to the bottom. Yeah. Difference factor 39. It's about right. 397, 385, 39, 3937. So the factor how much many times the second function could go into the time it took for the first function. So that's more accurate. Actually save those. See. Save those. So correct those. Save those. Then what we'll do now is remove that. Then we have basically got. God, now I can't get this head down. So now I'll remove the loop again. Doesn't need the loop steps. Okay. The test is done. So I'll remove all that. Let's leave one of them there. In case we need to copy paste it. Oops. There. There. No. Remove that. Let's check. That's what it does. Okay. Loop all gone. Save it, compile, and run. Let's check if we've got any other warnings here. Warnings. None. Warnings. Select none. Come on, none. Warnings. That's all the body things. You can't find this board. That's okay. Something else. that level doesn't have. If you load single levels, it doesn't have a settings save. That's not me either. What's that thing? Current project. Is this bad? It's empty. Or asset. It found the property and the file wasn't set, so that's okay. Well, it's not okay, but it's not a bug. Yet. It's not a bug yet. Any others? What was that? Input pin is also unknown to please correct not. That doesn't exist anymore. See the message log. Yeah. Okay, done. Variable set on the variable then. Something like that. Now it's repeating it. Just cascade people. Incomparable. That's also not me. Add it to the list. Like down here. To look at that later. So now we run it. We have this loop is gone. So we hook it up again. Yeah. Yeah. That over here. Remove that. So let's turn it with these loops instead. Come on. It's interesting to see what the ratios are. Not the ratios, the factors. Well, the ratios level. Factor ratio. Are you running? What's happening? No breakpoint. Do we have this on? Oops, yeah.
All systems are functional.
Back now. Okay. Reload our small level. And get the numbers from this. Which is now without the loop here and the loops in the blueprint. And just get the numbers. Some numbers. Okay, get a few. And we can pick up this button. Okay, it did. Let's do a few seconds with the weapon on. And aimed and not aimed. Okay. Get those numbers. Hopefully these are the last numbers we'll ever need. So, target you. Copy these. Get some of them here. And get them here. C++ loop, and now without. Using blueprint loop. Using C++ loop. Using blueprint loop for blueprint function, and using C++ function. Okay, the ratio here was 3739, 39, 39, 39, 39, so around 39. The ratio here 23, 2, 2, 2, 2, 1, 6, 2, 3, 2, 1, 8, so around 2, 1, 4, 2, 3, so with the loop iteration we're losing. Wait, it is printed out here as well. No. I didn't put no here. 39. I think I don't need that anymore. 50,000 calls. Forest loops, 50,000 iterations. So 39, 2, 2, 2, 2, 2, 1, 2, 3, 2, 1, 8, 2, 3. So you're using almost an entire cycle of the update function just for the for loop iteration, for one of the iterations of the loop, I would say. Even more. It took away even more. So, confirms I should not use for loops in blueprints at all. If I'm correct here now. So I'm quitting the stream. Unless I made a grave error somewhere. Don't think I did. Let's open it again. Last time to open it today. It's not here. Where was it? It wasn't even in here. So here. I understand. Okay. I'll just fix up the blueprint here and remove that entirely. So we don't need this. delete this node? Why can't I delete this node? Right here. Break this. I cannot delete that node. That is weird. Just be able to delete nodes. Fresh nodes. That is weird. Let's close that again. Open it again. That. Delete this one. Now it deletes it. Like that. I'll just use this instead. Because it's almost 4 times faster. So. It's QED. Or it's not QED. Is that QED? Oh, say so. Okay. Remove the print. Here, what do we print? Print target view. Delete that. And that's it. We'll end the stream.